Good morning, all of you. Okay, we'll continue with the radioactivity phenomenon. Now, read the question. There is an expression for average life of that one. So, what is actually the bringing? So, let me just put like this. This expression everyone knows, 1 by lambda, but some of the numericals what happen where how this derived, if you know it, no. So, I think you'll be in a better position. This one. So, some nuclei, n naught nuclei are there. Total number of nuclei, how much? N naught. Some nuclei, what happens, they're having a lifespan of 0. The moment substance is formed, they'll undergo decay. Some nuclei, what happens, they're having a lifespan of infinity. At t equals 0, what is the number? N naught. Then after a long time, t equal to infinity, it will become 0. Let's assume that it will be off like this. So at any instant of time, somewhere here, at t, the number of nuclei will be n, and at a small interval of time dt, the number, some dn nuclei will undergo disintegration. At time t, at t equals 0, let the number be n naught. At any time t, let the number be n. And in an interval of time dt, let dn undergo disintegration. So therefore, we'll put it like number of particles disintegrated in time dt. So how many particles will be disintegrated? So let it be dn. And what this dn should be equal to? Lambda n dt. Because what is the basic idea? Dn by dt is equal to minus lambda n. So dn, what we can write? Minus lambda n dt. In interval of time dt, let the number of particles disintegrated, let it be dn. Then what is the lifespan of each of this at time t? No, at time t, in a small interval of time dt, dn disintegrated. What was the lifespan? This was the lifespan. Lifespan of n atoms. Lifespan of n atoms. Shall we put it here? The lifespan of n nuclei. So next year, the lifespan of each of these nuclei is t. Then the sum of lives of all dn nuclei are next one. And just splitting up the meaning of the terms, the sum of lives of all dn nuclei are is will write, or better to write r is dn into t will write it. What is dn? Lambda n dt into t. Now let's go for the sum of lives of all that nuclei. The sum of lives of all nuclei that will present at t equal to 0. I'll call that S. So there should be 0 to infinity t lambda n dt. This one only, or that quantity lambda n dt into t. What is the average life? Average life, the symbol is what? This should be equal to t average. This should be the lifespan of all the nuclei by the total number of nuclei. So average life is equal to sum of lifespan It is there in SURMA. Same thing what is there in SURMA, I'm just writing it. So this should be equal to n by n naught. When you solve this, lambda n t dt 0 to infinity n naught, you'll end up with 1 by lambda. So therefore, the decay constant is something very important. And the decay constant, will it change with external parameters? No. For different substance, the value of lambda will be different. Half-life will be log 2 by lambda and the average life will be 1 by lambda. I think there's a formula everyone knows. Just there's a method of analyzing it. Okay, let's come for now. What all I discussed the problems. No, you go back to fluid dynamics. You have to correlate the logical idea of fluid dynamics. If you apply here very